I am from Hindustan College of Arts and Science. So the topic I am about to take is Bessels equation. First we take an equation, that is x square d square y by dx square plus x dy by dx plus x square minus n square whole into y equal to 0. Put it as equation 1. Then take y equal to a0 x raised to m plus a1 x raised to m plus 1, that equation, and write it in a summation form, that is y is equal to summation of r equal to 0 to infinity ar x raised to m plus r, and differentiate the above equation of y with respect to x. We get that summation of r equal to 0 x raised to m plus r ar x raised to m plus r minus 1, and again differentiate the dy by dx, we get d square y by dx square, that is summation of r equal to 0 to infinity ar into m plus r minus 1 into x raised to m plus r minus 2. So put the equation of y dy by dx and d square y by dx as equation 2 and substitute the equation 2 in the first equation. So in the first, when we substitute that, we get x square summation of r equal to 0 to infinity ar x raised ar m plus r into m plus r minus 1 x raised to m plus r minus 2 plus x into m summation of r equal to 0 to infinity ar into m plus r into x raised to m plus r minus 1 plus x square minus n square summation of r equal to 0 to infinity ar x raised to m plus r equal to 0. In the next step, from this first equation, x square minus n square, multiply the coefficient inside, then we get the third part of the equation we split into two, that is sigma of r equal to 0 to infinity ar x raised to m plus r plus 2 minus n square into sigma of r equal to 0 to infinity ar x raised to m plus r, that will be written as equation 3. In the next step, the coefficient which have x raised to m plus r is taken as common and written in the form of sigma summation of r equal to 0 to infinity ar into m plus r minus 1 plus m plus r minus n square whole multiplied by x raised to m plus r plus summation of r equal to 0 to infinity ar x raised to m plus r plus 2 equal to 0. Put it as equation number 4. And solving this equation, we get summation of r equal to 0 to infinity ar m plus r whole square minus n square whole into x raised to m plus r plus summation of r equal to 0 to infinity ar x raised to m plus r plus 2 equal to 0. Put it as equation number 5. Equating the coefficient of x raised to m at r equal to 0, but a naught equal to a naught into m square minus n square is equal to 0. For here, a naught is not equal to 0, that is m square minus n square equal to 0. From that, m is equal to plus or minus n. In the next part, equating the coefficient of x raised to m plus 1 at r equal to 1, we get a1 into m plus 1 whole square minus n square equal to 0. Here a1 equal to 0, that is m plus 1 whole square minus n square not equal to 0. The next part, we get equating the coefficient of x raised to m plus r plus 2. We have ar plus 2 into m plus r plus 2 whole square minus n square plus ar equal to 0. That is ar plus 2 equal to minus ar by m plus r plus 2 whole square minus n square. That is a1 equal to a3 equal to a5, that is odd numbers, all the odd numbers are equal to 0. So if r equal to 0, a2 equal to minus a naught by m plus 2 whole square minus n square. If r equal to 2, a4 is equal to a naught by m plus 2 whole square minus n square into m plus 4 whole square minus n square. So substituting all this equation in y, we get y equal to a naught x raised to m minus a naught by m plus 2 the whole square minus n square whole into x raised to m plus 2 plus a naught by m plus 2 whole square minus n square into m plus 4 whole square minus n square into x raised to m plus 4, and so on. The final equation we can written as y equal to a naught x raised to m into 1 minus 1 by m plus 2 the whole square minus n into x square in plus 1 by m plus 2 the whole square minus n square plus 4 whole square minus n square into x raised to 4 plus summation of the rest of that. And we can change the equation in the form of, we can put m equal to n or m equal to minus n. Thank you all for watching this video.